In today's examples, we're going to find the diagonal of a cylinder by using the Pythagorean theorem. We're going to label the diagonal as the hypotenuse, the C, and the height and the diameter as the legs, A and B. We're going to substitute these values into the Pythagorean theorem and then solve the equation for the diagonal. And then if needed, round to the nearest tenths. So here's our first example. Example A, we're going to find the length of the diagonal. We are given the height of the cylinder, which is given as 8, and we're also given the diameter of the cylinder, which is given as 6 feet. Notice how they meet at a right angle, therefore we have a right triangle formed with the diagonal. The diagonal will be the hypotenuse, the longest side of this right triangle, so the diagonal will be labeled with C for the hypotenuse. So let's continue and start to solve for C. So our steps, we're going to label A, B, and C, and then we're going to write A squared plus B squared equals C squared. Now, you could label either the 6 or the 8A and the other one B, just be consistent through your work. In this example, I labeled the A as the 8 and the B as the 6. So I substituted 8 in for the A and 6 in for the B. From here, you know how to do this. We're going to go through and evaluate those squares. So 8 squared is 64 and 6 squared is 36. And then we add those together, we get 100, and then you take the square root of both sides. And when you do that, you get 10. So the diagonal is 10 feet long.